So to solve the issue of storing the moves, I am going to create an array with 8 indexes, each index representing one of the moves that we want to try. And we can initialize the array with zeros, each zero representing one unused move. And as we generate a move, we will replace 0 with 1, and we'll do that for the index that corresponds with the index of the move in the horizontal and vertical arrays. So if we generate, for example, move with index 2, we try to perform corresponding move, which is, over here you can see, 1 space to the left and 2 spaces down. And if this move is not available to us, if the knight already came from the square that this move would land on, then in our index 2 of our move taken, we will place 1 instead of 0, indicating that we tried that move, but we didn't succeed because the move is not available. So as long as the used move array contains any zeros, we will keep trying to generate the moves because not all moves were tried yet. 0 means that the move was not tried yet. And if we generate a move that we can perform, then we simply perform it and exit the loop, and we won't care how many more moves are still possible to make because we just make one. And once all indexes in the move taken array contain integer 1 and there's no zeros, then we know that we tried all 8 moves, and since none of them resulted in a valid move, we end the tour because no more moves are possible from the knight's current position. And we can put it all into a while loop. All we need is a flag that will indicate that we tried all 8 moves, and when this condition is true, we exit the loop. So I simply have a boolean called all moves used. So this variable will serve as the flag for the loop, and we will loop while all moves used is false, meaning until there's at least one possible move to try. So now inside the loop, we can simply attempt the move by randomly generating it. So I simply generate a move between 0 and 7, which corresponds with the moves in our vertical and horizontal arrays. And now we can evaluate if the move is valid, but we should only do it if the move was not already taken. So we simply check if the I integer in the all moves used has a value of 0, indicating that the move was not attempted yet. Let's say we randomly generate move number 2, that would be index number 2, and we check if it's 0. If it is, then it's a move that we didn't try yet, and we can attempt it. If it already has 1, then we'll simply disregard the if statement and we'll try to randomly generate another move. So if the move was not attempted yet, we can try to make it. But before we do, we need to verify before we make it that it won't result in invalid move. So we can create a variable for the horizontal and vertical positions that will be our move if completed. And we can check if the move would fall on an empty cell, or if it would fall maybe on outside of the board, or on the cell that was already used. So here, my horizontal move variable simply takes our current position and adds the possible move that we are trying to make, and the same for the vertical. The vertical position takes the current vertical position and the corresponding vertical position it would be in if we attempted the move. So there's only a few things that we need to check to see if the move can be made. First, we check if the move would be outside of the board. And it's a very simple check. We see if the horizontal move would be outside on the left or right, and if the vertical would be outside top or bottom. And since the board is a square, in both cases, we check if the move is greater than 0, because that is the first index in the array, corresponding with the top row and left column, and we check if the move would be greater than last index on the board, which is 8 in 8 by 8 board. But of course, we will use the constant variable for the size instead of hard-coding the value. So the board size index corresponds with the bottom row and the right column. So again, we are checking if the value for the horizontal move is between 0 and 8, and for the vertical, the same thing, whether it's between 0 and 8. But it's not good enough if the move is within the board boundaries. We also need to make sure the knight would not fall on a cell it was already visited. Remember, we have a symbol of dot for empty cell and X for the night. So as long as the move falls on a cell with the value of dot, we know it's an unused cell and we can make the move. So we can simply check if the horizontal and vertical move would land on a cell with a dot. So we will do an AND, and we'll check in our board, on the chessboard, with the H move and vertical move. Remember, these are our moves that we're trying to attempt, and we see if it's an available cell by checking if it's the board symbol. So this is our complete position. We check in if it falls outside of the board or if it falls cell that we can go on. And that's all we need to verify. So now, if all these conditions are true, we can make the move. So we can assign the future move that we just verified as valid to our current position. So remember, our current horizontal will equal the future move that we just verified, and the same for the vertical, but it will obviously equal the vertical move that we verified. And now we can replace the dot character with the X character, indicating that the knight has visited the cell. So we go to our board again, and this time the coordinates are our current move, because that is where we are currently. We just made the move, so the horizontal and vertical, and it was a dot, but now we'll replace it with the move symbol. And finally, we simply add the move to our move count. So we will increase our move count by 1. At this point, we completed the move, and there's nothing else we need to do or check, so we can exit from the method and just use the return statement as true. Yes, we are moving because we just completed the move. Now we still need to code a few things here. Remember, the above related to a valid move. However, if the move would end up in the cell that was already visited, then it is not a valid move, or outside of the board. Again, it's not a valid move. So we don't perform it, however, we still have to register it in our array of moves that we tried. So we need to replace the integer 0 with integer 1 in our moves taken array, so next time we try this move, we already know that it was tried. So if we didn't make the move, we'll still register it. So moves taken, and we are registering the move with the same index, so the index is I, that's the number that we generated as the random move we tried to attempt, and we put 1 in there. Alright, at this point, we either made a move or we registered it as an invalid move. So all that's left is to check if we already tried all 8 moves. Remember, we loop until all moves were tried, and if they were tried, we exit the loop and end the tour as incomplete. So after our if statement, we make another if statement, checking if the number of moves we tried equals 8. But how do we know if we tried all 8 moves? As I said before, there will be no zeros in our array. And if there's no zeros, that means that all indexes contain integer 1. So we can simply loop through the moves taken array and add all indexes together. And if the sum of all values equals 8, then we know that all 8 indexes contain integer 1, and therefore all the moves have been taken. So I'm using a simple for loop, and in each iteration I add the value of each move to the previous sum of values. And after the loop, we can check if the variable c now equals 8. And if it does, then all moves were taken, and we can set the all moves used variable to true. And at the end, after we determine that we're stuck and cannot move, and the loop exited, we increase the tour counter because we just finished another incomplete tour. So after a while loop, we will increase the tour counter by 1. And of course, at this point we return false because the tour ended incomplete. Okay, so this is our move validation method, and in the next video we will code a method that will move the knight and collects the statistics. So thanks for watching, I'll see you in the next video.